My name is Quentin Leguito, and I'm an 11th grader at Palos Verdes High School. Now, the title of my project is The Influence of Different Front Splitter and Rear Diffuser Designs on the Ground Effect Performance of a 112 Scale RC Car. Aerodynamics play a very crucial role in the performance of high-speed vehicles such as the Formula One series. Now, this series uses a force known as the ground effect to produce most of their downforce. The ground effect is essentially the interaction between the underside of the car and the ground when airflow passes through the car. My project investigates how various underbody aerodynamic components could be designed and mounted so that the aerodynamic efficiency of the car was improved. My hypothesis was that integrating these parts as a full system would provide the greatest increase in cornering speed. I was able to design these parts using Fusion 360 CAD software, and I then used the SimScale computational fluid dynamics software to actually visualize how airflow responded and was affected around the car when these components were integrated before I actually 3D printed them out. To 3D print these, I used a Bambu Lab A1 3D printer, and I used PETG CF filament. Now, to test how I actually tested the cornering speed of these various components, I took a video of the car, and I then measured how long it took for the car to go from a fixed starting position to a fixed ending position. Since my video was at 30 frames per second, I was able to count the number of frames it took for the car to go from the starting position to the ending position, and from there I was able to calculate how long it actually took for that car to reach the ending point. From there, I was able to calculate the average cornering speed for the car over the corner, and I was able to obtain values of this for all the different combinations. I had the control car, just a singular part on the car. I had 2-part combos, and then I had the full system with all 3 parts combined. Now, the baseline car produced the slowest average cornering speed. The single part combos produced marginal increases in cornering speed, but they were nothing noticeable compared to the 2-part combos and the full system, with the 2-part combos having a larger increase in cornering speed, somewhere around that 15 to 16% mark. And then the full system was able to reach a percent improvement of 24% over the other combinations and the baseline configuration. Now, this supports the hypothesis that introducing a front splitter, rear diffuser, or side skirts increases the cornering speed of the vehicle, and that the ground effect is a noticeable force that can be effectively used even in smaller scales. Some improvements I can make to the project would be to see how changes in the diffuser angle affect flow separation and the traction of the car. I could also see how changes in ride height affect the cornering speed of the car, and I could also introduce an active aero system which would use servos to be able to change that diffuser angle and even the angle of the front splitter on the go.